Good morning, students. Continuation of the last class. We have constructed truth tables for P and negation P, negation of negation P. And the last one is truth table for P, 15th page. And then continuation. Now, construct the truth table for P arrow mark Q and Q arrow mark R implies P arrow mark R. Now, how many variables are there here? Three variables are there. Next, we have to identify the simple compound statements. The first one is P arrow mark Q, second one is Q arrow mark R, third one is P arrow mark R, and this fourth one is P arrow mark Q and Q arrow mark R. Next, this whole implies P arrow mark R. This is as it is given statement. P arrow mark Q and Q arrow mark R whole implies, this floor brackets implies P arrow mark R. This one is P arrow mark R. This one, right? Now, how many possible values for the truth values? Now, how many variables are there? Three variables. For each variable, how many possible truth values are there? Two. One is true, next one is false. That's why 2 to the power of number of variables. 2 power 3, how much? 2 into 2 into 2. 2 2s are 4, 4 2s are 8. That's why you will get 8 possible combinations. All may be true. First, P may be true, Q may be true, R may be false, right? Next, P may be true, Q may be false, R may be true. P may be false, other two. It means Q and R are trues. Like this. Now we'll get 8 possible combinations. Now we are writing the implication P arrow mark Q. Right? What do you mean by implication? You have to remember one statement. What is that? A true statement cannot imply a false statement. Right? Now, P, true implies true, true. True implies true, true. True implies false, false. False implies true, true. True implies false, false. False implies true, true. False implies false, true. False implies false, true. Next one is Q arrow mark R. That means the implication of Q and R. Q implies R. Now these two columns. True implies true, true. True implies false, false. False implies true, true. True implies true, true. False implies false, true. True implies false, false. False implies true, true. False implies false, true. Similarly, P and R, the implication of P and R is denoted by P arrow mark R. Now these two you have to consider, this column and this column, first column and third column. That means true implies true, true. True implies false, false. True implies true, true. False implies true, true. True implies false, false. False implies false, true. False implies true, true. False implies false, true. Next one is conjunction of these two. Conjunction of these two. P arrow mark Q and Q arrow mark R. Now true and true, true. True and F, F. False and true, false. True and true, true. False and true, false. False, true and false, false. True and true, true. True and true, true. And the last one is the given compound statement as it is. That means this one implies this one in our statement, right? T implies T, T. F implies F, T. F implies T, T. T implies T, T. F implies F, T. F implies T, T. T implies T, T. T implies T, T. Here the last column of the compound statement contains all truths. Therefore, the given compound statement is a tautology. Now we are not writing that conclusion because our question is construct the truth table for the given compound statement. That's it, right? In the next example, now negation P and negation Q and R, or Q and R, or P and R. Now again we have to construct the truth table. How many variables are there? Three variables, P, Q, R, right? Now you are writing how many combinations you will get. 2 to the power of 3, that is 8 combinations, right? Now see, 1, 2, 3, 4, 5, 6, 7, 8. Now similarly you are finding negation of Q, negation of P, disjunction, conjunction, again conjunction. Now here the last column is what? Now how many compound statements are there? Negation P is one compound statement, negation Q is another compound statement, negation Q and R, negation Q and R, Q, R, R, P and R. Now combining these two, negation P and negation Q and R, you will get this one. Now combining these two, Q, R, 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 P and R. Now this whole thing, this in R, this one. See, 1 or 2. 1 means I am writing this one as 1, this one as 2. Now you have to combine these two by using an operator R, right? Here you have to write as it is the given statement. The given statement as it is we have to write over here, right? Now again those possibilities we have to construct the truth table. Here the last column of the truth table contains some truths and some false, therefore it is a contingency, right? Next, continuations, 17th page. Now see, write the following statements in symbolic form. Symbolic form means some statements are given to you, we have to break the compound statements into simple statements. Now we have to assign the some notations, right? Now here the first one is, if either Tom takes calculus or Gopi takes sociology, then Kiran will take English. One compound statement is given to you, right? Now you have to identify the simple statements. In the first one, Tom takes the calculus is a simple statement. Now that one I am denoting it by P. The next one, Gopi takes sociology. It is also a simple statement. That one I am denoting it by Q. Then Kiran will take English. Or you can write Kiran takes English, or you can write Kiran will take English. Both are correct. Kiran will take English, or you can write Kiran takes English. That is denoting by R. Here, if, then, if, or, then, these are connective words. If, then is a connective word, or is a connective word. Now, two or more statements are combining with some connective words. That whole entire newborn statement is called a compound statement. Now, symbolic form, here if, right? If P. Now, what you are writing? If P or Q, this is P or Q, then Kiran will, that means P or Q implies R. This can be written as if P or Q, then R. If P or Q, then R. If you want, you can write. If P means what? Tom takes calculus, or Gopi takes sociology, then R means Kiran will take English, right? Now, the second one, the crop will be destroyed if there is a flood. The crop will be destroyed if there is a flood. Now, here P is equal to, again, one compound statement is given to you, right? Now, this is if is a connective word. Two simple statements are combined by a connective word, that is if, right? Now we are identifying the simple statements. The crop will be destroyed. That is denoted by a letter P. There is a flood. That one we are denoting by Q. Or sorry, this is Q, right? Now in symbolic form, the first sentence is P, the connective word is if, the last sentence we are denoting it by Q, which can be written as P if Q. P if Q is nothing but what? Q arrow mark P. That is nothing but implication form, no? Right? Now, the next one, equivalence. Now, this is the definition. Two compound statements are said to be equivalent, or you can say logically equivalent, if their truth tables are identical for all for all possible truth values. Now, here P and Q be two statement formulae. Formulae means two compound statements. P is a compound statement, Q is a compound statement. Let P1 comma P2 and so on Pn denote all the variables occurring in both P and Q. That means P is a compound statement which contains P1 comma P2 and so on Pn, right? Whereas Q is also a compound statement which contains P1, P2 and so on Pn. These two statement formulae are said to be equivalent if their truth value is their truth value is same. That means the truth value of the compound statement P is equal to the truth value of the compound statement Q. Then we can say that both the statements, that means compound statements, are equivalent, right? There is another one. Two compound statements are said to be equivalent if their truth values are identical for all possible truth values of the compound statements, right? Now, example, negation of negation P is equivalent to P. P or P is equivalent to P. That means if you construct the truth table for this one, that truth table is also equal to the truth table of P. Here, negation of negation P truth table is equal to the truth table of P. This is one prepositional formula. This is one another prepositional formula. Now these two prepositional formulas are equivalent. Endukani? Because their truth table is same. Now, the two statement formulae, or you can say compound statements, are equivalent provided their biconditional is a tautology. It's a point you have to remember. That means P and Q are equivalent. P is one prepositional function, or you can say compound statement. Q is another compound statement. Those two statements are equivalent if P implies and implied. That means if and only if Q is a tautology, right? Now, these are the equivalent formulas you have to by heart. Now, you can write is equal to or two-sided arrow mark with double lines, right? Now, this is a symbol for equivalent, right? Now, P or P, P and P is equal to P. These are called idempotent laws. Now, this is called associative law. You know, A plus B plus C is equal to A plus B plus C. In the case of multiplication, A into B into C is equal to A into B into C. That is called associative law. Here, manakemina symbols R symbol and AND symbol. These are called associative laws. Similarly, commutative laws P or Q is equivalent to Q or P. Suppose in case of addition numbers, by taking an example, 1 plus 2 is equal to 2 plus 1, no? Or in the case of multiplication, 1 into 2 is equal to 2 into 1. These are called commutative laws, right? Now, this is called distributive law. Now, P R Q and R is equal to P R Q and P R R. Similarly, P and Q R R is equal to P and Q R P and R. These are called distributive laws, right? Next one, these are called absorption laws. You have to remember these laws. Absorption laws. P and Q is equal to P. P and PRQ is equal to P. Right? These are called absorption laws, like De Morgan laws. Negation of PRQ is equal to negation P and negation Q. Similarly, negation of P and Q is equal to negation P or negation Q. These are called De Morgan laws. Next, identity laws. P or false is always equal to P. P and true is always equal to P. Right? Now, P or T is equal to true. P and false is equal to false. Now, these are called domination laws. Now, negation of negation P is equal to P. This is called law of double negation. మరి మీకు ఆల్రెడీ డిమోర్గాన్ లేస్ తెలుసును. ఏ యూనియన్ బి హోల్ డాష్ ఈజ్ ఈక్వల్ టు ఏ డాష్, ఏ యూనియన్ బి హోల్ డాష్ ఈజ్ ఈక్వల్ టు ఏ డాష్ ఇంటర్సెక్షన్ బి డాష్. అలా సిమిలర్లీ ఏ ఇంటర్సెక్షన్ బి హోల్ డాష్ ఈజ్ ఈక్వల్ టు ఏ డాష్ యూనియన్ బి డాష్. దోస్ ఆర్ కాల్డ్ డి మోర్గాన్ లాస్. ఇది సిమిలర్గా ఉన్నాయి. హియర్ వీఆర్ యూజింగ్ వాట్? ఇన్స్టెడ్ ఆఫ్ డాష్ ఆర్ బార్ వీఆర్ యూజింగ్ నెగేషన్. Instead of union and intersection, here we are using conjunction and disjunction. Now, simplify the following compound statements by using those standard laws. Now, see, first one is P or Q and negation of negation P and Q. Right? Now we have to simplify this one by using distribution, by using the laws, right? Equivalent laws.